Tonight, we're going to explore the true scale of Andromeda. This is not something you need to understand all at once. You don't need to remember every detail, or track every light year, or memorize the staggering number of suns we are about to discuss. You can simply listen and allow your thoughts to drift as we move slowly outward from the world you know. To begin, let's start with something familiar, perhaps the room around you or the weight of the air. We often feel that our world is vast, and in many ways, it is. But as we look toward the great galaxy in Andromeda, we begin to realize that our definitions of large and far are merely local approximations. Tonight, we will step beyond those approximations. There is no rush. The universe moves with a patient, tectonic grace, and we shall do the same. Consider the walls of your room, the ceiling above, and the floor beneath you. These boundaries provide a sense of security and proportion. We measure our lives in these small increments: the distance from the bed to the window, the length of a street, the duration of a single afternoon. However, the light we are contemplating tonight has spent millions of years traveling through a vacuum so profound that it challenges our basic understanding of existence. This is not a journey of miles, but a journey of epochs. As you lie still, imagine the scale of a single human life compared to the slow, rotational period of a galaxy containing 1 trillion suns. It is a comparison that does not diminish us, but rather invites us to set aside our smaller anxieties in favor of a much grander, much quieter perspective. Tonight, we are exploring a neighbor that is simultaneously unimaginably distant and cosmically close. Andromeda is the largest architectural structure in our local neighborhood, a swirling disk of ancient fire and dark matter that rests in the deep velvet of the constellation that bears its name. We often speak of the true scale of such things, but the truth is that the human mind was designed to track the movement of clouds and the changing of seasons, not the collision of galactic halos. Therefore, we will not try to grasp these numbers with force. Instead, we will let them wash over us like a slow-moving tide. As we begin this exploration, let your breathing find its own natural, easy rhythm. There is nothing you need to solve. There are no questions that require an immediate answer. We are simply observers on a very small, very comfortable porch looking out across a 2.5 million light-year garden. The light from Andromeda is reaching us now, ancient and weary, having bypassed countless stars and crossed the great void just to settle here in this moment. If you enjoy these deep explorations in space, consider subscribing or hitting the like button. It really helps the channel grow and allows me to make content like this. When we think about the Andromeda galaxy, we often imagine it in human terms. We think of it as a destination or a photograph in a textbook. We measure it in distances we can walk or time we can measure in years. But to truly understand Andromeda, we must first look at the limits of our own senses. If you were to walk outside on a truly dark night, away from the hum and glow of the city, you might see a small, faint smudge of light in the constellation of Andromeda. It looks like a thumbprint made of dust. It is the most distant thing the human eye can see without the help of glass and mirrors. Consider a long walk. If you were to walk across your own country, it might take months. To our ancestors, that distance was an odyssey. If you were to drive a car at highway speeds toward the moon, it would take you about 6 months to arrive. To reach the Sun, it would take over 150 years. These are scales that already exhaust our daily imagination. But Andromeda is not a destination in our neighborhood. To imagine the distance to Andromeda, imagine a single grain of sand representing the Earth. The Sun would be a small marble just a few feet away. On this scale, the Andromeda galaxy would be another vast collection of sand located over 2,000 miles away. This comparison isn't perfect, but it gives us a calm place to begin. It reminds us that our perspective is built for the ground beneath our feet, while the universe operates on a scale that is comfortably and quietly indifferent to our measurements. To understand the great galaxy in Andromeda, we must first acknowledge the limits of our own biology. We are creatures of the surface, evolved to understand the distance a spear can be thrown or the distance a person can walk before the sun sets. When we speak of millions or billions, the brain treats these numbers as abstract poems rather than physical realities. We need anchors, small, steady weights, to drop into the ocean of the cosmos so that we do not lose our sense of place. Imagine, for a moment, that you decided to walk to the moon. If there were a bridge spanning that silvery distance and you maintained a steady, brisk pace, it would take you roughly 9 years of continuous walking without sleep or pause to reach the lunar surface. To a human being, 9 years is a significant epoch. It is the time it takes for a child to grow into a student, or for a young tree to take firm root in the earth. And yet, the moon is our immediate neighbor, a mere stone's throw in the darkness. If you were to point a laser at the moon, the light would arrive in just over 1 second. 1 second of light travel time equals 9 years of human walking. This is the first fracture in our understanding of scale. Now, consider the sun. If you were to board a commercial jet and fly toward our star at 500 miles per hour, you would not arrive this year. You would not arrive in your lifetime. The journey would take 19 years of constant flight. If you had started this journey as a young adult, you would be approaching middle age by the time the heat of the sun became a physical embrace. Yet, light makes this journey in 8 minutes. When you look at the sunset, you are seeing the sun as it was 8 minutes ago. You are already looking into the past, even in your own backyard. These 8 minutes of light travel represent the boundary of our inner solar system, a space so large it dwarfs the history of many nations, yet so small it is invisible on a galactic map. To find Andromeda, we must look much further than 8 minutes. We must look further than the years it would take to walk to the moon. We must begin to think in terms of generations and civilizations. If we were to represent the entire Earth as a single microscopic grain of salt, the sun would be a small glowing ball about the size of a grapefruit, located roughly 50 feet away. On this scale, the farthest reaches of our solar system, the icy fragments of the Oort cloud, would extend for miles. But where would Andromeda be? In this world where the Earth is a grain of salt, Andromeda would not be in the next town or even the next state. It would be thousands of miles away, an entirely different continent of salt grains, drifting in a darkness so profound that the space between us is almost entirely empty. It is helpful to think about the historical humor of our own discovery. For centuries, the finest minds in astronomy looked at the smudge in the constellation of Andromeda and argued about what it was. To the naked eye, it is a nebula, a word that simply means cloud. In the 1700s, some observers thought it was a hole in the heavens, a place where the stars had been swept aside to reveal the glowing primordial fluid of creation. There is a certain gentle irony in the fact that we looked at a collection of 1 trillion suns and thought it was a small puddle of celestial gas. We didn't have the scale, we didn't have the context. We were like ants standing on the edge of the Pacific Ocean, wondering if the blue shimmer on the horizon was a particularly large dewdrop on a nearby leaf. The shift in our perspective happened slowly. It required us to find yardsticks in the sky stars that pulse with a regular heartbeat, known as Cepheid variables. When Edwin Hubble used the Great Telescope at Mount Wilson to find one of these pulsing stars inside the Andromeda Nebula, he realized the pulse was too faint. It was far too dim to be inside our own galaxy. In that moment, the universe grew millions of times larger. The cloud was not a cloud. It was an island universe. It was a home to billions of possibilities, existing entirely independent of our own. To visualize the distance of 2.5 million light-years, think of the oldest structures built by human hands. The pyramids of Giza were built roughly 4,500 years ago. This is a vast stretch of human history, but the light we see from Andromeda tonight left its stars long before the first stone was cut for a pyramid. It left before the first cities were settled in Mesopotamia. It left when our ancestors were just beginning to use stone tools on the African savanna. That light has been traveling through the absolute cold of the void for every second of every minute of every hour of the last 2.5 million years. It traveled while empires rose and fell. It traveled while the ice ages advanced and retreated. It traveled while you were born, and while you grew, and while you laid down tonight to listen to this story. The true scale of Andromeda is not just a measurement of length, it is a measurement of patience. The galaxy does not care that it takes 2.5 million years for its image to reach us. It is not in a hurry to be seen. It operates on the long time, the deep, slow rhythm of gravity and orbital mechanics. In Andromeda, a single galactic year, the time it takes for the galaxy to rotate once, is roughly 250 million years. Since the time of the dinosaurs, the Andromeda galaxy has only turned around a few times. When we contemplate this, the stresses of our 2-4-hour cycles begin to feel like the buzzing of a mayfly. A mayfly lives for a day, a human lives for 80 years, a star lives for 10 billion years, and a galaxy exists as a coherent structure for even longer. By placing ourselves in the human scale perspective, we aren't trying to feel small. We are trying to feel the weight of the air, the comfort of the bed, and the reality that we are part of a system that is incredibly stable. The distance to Andromeda is a buffer. It is a vast, protective silence that ensures the chaos of one galaxy does not easily disturb the peace of another. We are separated by a gulf of space so wide that even the fastest information in the universe takes millions of years to cross it. This means that, in a very real sense, the universe is a collection of stories that are all being told at different times. We are reading the Andromeda story from 2 million years ago, while someone in Andromeda, if they were looking at us, would be seeing the Earth as it was in the Pliocene epoch, long before the first campfire was ever lit. As you drift closer to sleep, let the numbers lose their sharpness. You don't need to hold on to the 2.5 million or the 1 trillion stars. Just hold on to the feeling of the distance. It is a soft distance. It is a quiet distance. It is the space between two great ships passing in the night, so far apart that their lights are just pinpricks on the horizon. We often worry about being insignificant in the face of such scale, but insignificance is just another word for freedom. If the universe is this large and Andromeda is this vast, then we are free from the burden of having to be the center of everything. We can simply be here, in the room, with the weight of the air and the rhythm of our own breath, knowing that the great galaxy is also there, doing exactly what it has done for billions of years. It is spinning, it is glowing, it is waiting for its light to find its way to our eyes. This brings us to the edge of our human understanding. We have used our walking, our flying, and our history to try and map the void, but now we must step beyond the anchors. We must move from the grain of salt to the actual stars. When we look at the Andromeda galaxy, we are not just looking at a place. We are looking at the ultimate challenge to our sense of proportion. To a human being, a journey of 1,000 miles is a significant undertaking. To a planet, it is a microscopic tremor. To a galaxy like Andromeda, it is a distance so small that it does not even qualify as a measurement. It is the width of a single hair on the head of a giant. Imagine the sheer physical presence of the world you inhabit. Think of the tallest mountains you have ever seen, the vastest oceans you have ever crossed, and the seemingly endless canopy of the sky. These things feel permanent and immense. But if we were to take the entire Earth, every mountain range, every deep-sea trench, every city and every person and shrink it down to the size of a single grape, the scale of the cosmos would still remain hauntingly empty. On this scale, the Sun would be a large exercise ball located about 2 football fields away. The nearest star system to our own, Proxima Centauri, would be another exercise ball located roughly halfway around the circumference of the Earth. And Andromeda. On this scale, where the Earth is a grape, Andromeda would be a collection of trillions of objects located further away than the actual Moon is from the actual Earth. This is why we feel a sense of cosmic vertigo when we peer too deeply into the dark. Our brains are beautifully adapted for the middle ground. We understand the speed of a running horse, the height of a tree, and the passage of the 4 seasons. We are built to navigate the human scale, but the universe does not share our limitations. It operates on a scale that is comfortably and quietly indifferent to our measurements. The Andromeda galaxy contains roughly 1 trillion stars. If you were to sit down tonight and try to count them, one by one, at a rate of 1 star per second, you would not finish by dawn. You would not finish by the end of the year. You would not finish in your lifetime, or the lifetime of your children. You would have to sit there counting every second for over 31,000 years just to reach the end of that single galaxy. When we realize this, the historical humor of our early astronomical efforts becomes clearer. For centuries, we viewed Andromeda through primitive lenses, seeing only a faint, fuzzy nebula. We assumed it was a small cloud of gas, perhaps a few light years across, tucked neatly inside the borders of our own Milky Way. We were like sailors looking at a distant, massive continent and assuming it was merely a low-hanging cloud on the horizon. It took the work of Henrietta Leavitt and Edwin Hubble to provide us with the standard candles, the pulsating stars that finally allowed us to measure the true depth of the canyon between us. They discovered that the cloud was not a cloud at all, but a sister city of light, sitting 2.5 million light-years away. To understand the true scale of this distance, We must abandon our reliance on miles and kilometers. They are too small, like trying to measure the Atlantic Ocean with a thimble. Instead, we use the light year. Light is the fastest thing in existence, a cosmic speed record that cannot be broken. It travels at 186,000 miles per second. In the time it takes you to inhale and exhale, a beam of light could have circled the Earth dozens of times. Yet, even at this impossible speed, light takes 2.5 million years to reach us from Andromeda. When you look at that smudge in the sky tonight, you are seeing light that began its journey when our ancestors were just beginning to walk upright on the African savanna. You are looking at a living ghost. There is a profound stillness in this realization. It means that the universe is not just a place of space, but a place of time. To look out is to look back. The further we peer into the distance toward Andromeda, the further we are traveling into the past. We are seeing the galaxy as it was, not as it is. If Andromeda were to suddenly vanish tonight, we would continue to see it shining in our sky for another 2.5 million years. The sky is a tapestry of ancient history, a collection of light signals that have been traveling through the absolute zero of the void for eons, just to arrive at your eyes in this specific moment. As you drift closer to sleep, consider the human scale of your own life within this context. We often feel a sense of urgency and need to hurry, to achieve, to move. But the stars in Andromeda have been rotating in their slow, gravitational dance for 10 billion years. They are not in a hurry. A single galactic year for Andromeda, the time it takes for the galaxy to complete one rotation, is hundreds of millions of Earth years. To the stars, our entire recorded history is less than a blink. This is not meant to make our lives feel small, but to make our worries feel light. If the universe can hold 1 trillion suns in a state of perfect, enduring balance for billions of years, surely it can hold your thoughts for a single night. The transition from the grain of salt to the actual stars is a transition from the world of things we can control to the world of things that simply exist. We can map the moon, we can send probes to Mars, and we can even touch the outer reaches of our solar system with our technology. But Andromeda remains a masterpiece of distance. It is the great other, a reminder that there are structures in this universe so vast that they can only be appreciated through the lens of humility. Scientists continue to refine our understanding of this scale by looking at the proper motion of the stars. They use satellites to track the tiny incremental shifts in position that happen over decades. What we know so far suggests that Andromeda is not just sitting there. It is a dynamic, living entity. It has satellite galaxies, smaller islands of light like M32 and M110 that orbit it like moons orbiting a planet. It has a supermassive black hole at its center, a gravitational anchor that weighs as much as 140 million of our suns. This black hole is the eye of the storm, the quiet point around which 1 trillion stars revolve in a silent, luminous whirlpool. And so the universe continues, expanding, cooling, changing, slowly, quietly, endlessly. You don't need to stay awake for this part. The universe will still be here, moving gently forward, long after this moment passes. We have traveled from the floor of your room to the ancient heart of the great galaxy in Andromeda, and now we find ourselves at the edge of the map, where the lines of time and space blur into a soft, monochromatic haze. This is the place where the story does not end, but simply broadens until the individual words are no longer necessary. It is the infinite ending, the realization that the cosmos is a process that never truly stops, but merely changes its frequency. Imagine the galaxy not as a collection of stars, but as a slow, rhythmic breath. The inhalation took billions of years, drawing in the primordial gases of the Big Bang to forge the first suns of Andromeda. The exhalation is happening now, a long, cooling sigh that disperses light and heat across the 2.5 million light-year void. There is no urgency in this breath. It is the deep, steady respiration of a system that is perfectly at ease with its own scale. As you lie in the stillness of your own room, your breath is a microcosm of this cosmic rhythm. Each inhale is a gathering of energy. Each exhale is a release back into the continuity of the atmosphere. You are breathing with the galaxies. Over immense spans of time, the specifics of our journey, the numbers, the names of the constellations, the physics of the blue shift, will all settle like dust at the bottom of a clear lake. What remains is the stillness of the water. Scientists tell us that the universe is headed toward a state of maximum entropy, but in the infinite ending, we recognize this as the ultimate form of rest. It is the moment when the tension between things finally dissolves. The gravity that once pulled Andromeda toward the Milky Way will eventually finish its work, and the two will rest as one. The stars that once burned with a fierce blue heat will eventually fade into a gentle amber glow, and then into the quiet dark of dwarf stars and cinders. There is no goodbye in the cosmos, for nothing ever truly leaves. The atoms that make up the great galaxy are the same atoms that make up the air in your lungs and the pillow beneath your head. We are all participants in a closed loop of matter and energy. When we speak of an ending, we are only speaking of a transition. The light from Andromeda that finds your eyes tonight is not a final message. It is a single frame in a film that has been playing for billions of years and has no final scene. The universe is not a story with a climax and a conclusion. It is a symphony that repeats its themes in ever larger and ever quieter movements. Consider the infinite ending of the light itself. A photon travels for millions of years, never aging, never slowing, until it touches a surface. In that moment of contact, the photon's long journey ends, but its energy is transformed. It becomes warmth, it becomes a chemical signal, it becomes a thought. The light of Andromeda is currently being transformed into the peace you feel right now. The vastness of the 2.5 million light years is being distilled into the simple, quiet reality of your relaxation. This is the ultimate purpose of the scale, to provide a space large enough for your mind to finally let go. As you drift into the deepest layers of sleep, the image of Andromeda remains as a soft, glowing anchor. It is not a place you need to go, it is a place that is already here. It is a reminder that the dark is not an empty void, but a rich, supportive medium. The darkness between the stars is what allows the stars to be seen. The silence between the words is what allows the story to be heard. You are entering that silence now. You are becoming part of the full silence that we explored in the heart of the void. The universe will continue to expand. The dark energy will continue to push the distant superclusters over the horizon of the observable world. But here, in our local neighborhood, the bond between the Milky Way and Andromeda remains unbreakable. We are travelers on the same ship, heading toward the same golden equilibrium. The true scale of our existence is not measured in miles, but in the endurance of this connection. We are part of a trillion-star family that has been together since the dawn of the light, and for now, that uncertainty is simply part of the picture. It doesn't need to be resolved tonight. You don't need to know the fate of the last star or the final cooling of the vacuum. The universe is managing those details with the same patient, tectonic grace it has always used. You are free to withdraw your attention from the mechanics of the world. You are free to sink into the soft, velvet dark of the infinite ending. The light is dimming. The rotation is slowing. The distance is becoming a bridge of pure, silent peace. The stars of Andromeda continue to shine, even if no one is watching. The gravity continues to pull, even if no one is measuring. The universe continues to move, quietly and endlessly, toward a state of perfect balance. You are part of that balance. You are a steady pulse in a vast and beautiful system. There is no need to stay awake for the end, because the end is just a way for us to begin again. The light that began its journey 2.5 million years ago has finally found its rest. And as that light settles, so do you. The journey is complete, and yet it is always unfolding. The scale is vast, and yet it is intimate. The universe is far, and yet it is home. We have looked into the deep well of time and seen the shimmering disk of Andromeda, not as a cold and distant object, but as a sister, a companion, and a future part of ourselves. As you lie in the quiet of this moment, the atoms of your body, forged in the same high-pressure crucibles of ancient stars, recognize the rhythm of the cosmos. There is no longer a need to measure, to categorize, or to grasp. The universe is not a problem to be solved, it is a presence to be felt. Imagine the finality of a photon's journey. For 2.5 million years, it has known only the straight line of the vacuum. It has survived the expansion of space and the gravitational tugs of invisible dark matter. Now, it has reached its destination, the soft surface of a leaf, a grain of dust, or the retina of an eye. Its journey ends in a tiny spark of energy, a microscopic warmth that is absorbed into the fabric of the earth. In the same way, let your thoughts find their final resting place. The curiosity that carried you across the light-year bridge and through the galactic halo is now gently subsiding, transforming from active inquiry into a warm, heavy sense of belonging. You are no longer traveling. You have arrived. And so, the universe continues, expanding, cooling, changing, slowly, quietly, endlessly. This is the infinite ending, a state where the boundaries of time become fluid. When we speak of the end of a story, we usually mean a stop, a closing of a book. But the universe does not close. It simply turns the page to a chapter of lower density and greater peace. In the far future, the stars of Andromeda and the Milky Way will have finished their merger. The bright, chaotic spiral arms will have smoothed out into the serene golden orb of Andromeda. The frantic birth of new stars will have slowed to a rhythmic, predictable pulse. The universe is moving toward a state of equilibrium, a cosmic afternoon where the heat of the day has passed and the long, cool evening begins. Scientists look toward this horizon and see the dark era, a time trillions of years from now, when the last stars will have flickered out, leaving behind a universe of black holes and iron stars. To our human minds, this sounds like a lonely conclusion, but from the perspective of the infinite ending, it is the ultimate expression of rest. It is a universe that has finally finished its work. It has converted all its potential into experience. It has told all its stories. There is a profound, abstract humor in our desire for things to last forever in their current form. We want the stars to stay bright and the galaxies to stay separate, yet the universe knows that true peace lies in the dissolution of those boundaries. It is the transition from the doing to the being. As you drift, consider the infinite ending as a physical sensation of weightlessness. You are held by gravity, but you are not bound by it. The same force that keeps Andromeda in its orbit is the force that keeps you tucked safely in your bed. It is a constant, unwavering pressure, a universal hug that never lets go. You do not have to hold yourself up. You do not have to maintain your own orbit. You can simply let the curvature of space-time carry you along. The Earth is rotating at 1,000 miles per hour. It is orbiting the Sun at 67,000 miles per hour. The Sun is racing through the galaxy, and the galaxy is falling toward Andromeda. Yet, in this room, in this moment, there is only stillness. This is the gift of scale. The larger the movement, the more peaceful it feels to those within it. The scale of Andromeda is vast, yes, but it is also intimate because it is composed of the same fundamental building blocks as your own heart. The hydrogen that powers the fusion in 1 trillion distant suns is the same hydrogen that makes up the water in your cells. There is a continuity of matter that ignores the distance. You are a localized knot in a 2.5 million light-year long string. When you pull on one end, the other end feels it. When you breathe, the universe adjusts. This intimacy is the antidote to the cosmic vertigo we felt at the beginning. We are not lost in the void. We are the void's way of knowing itself. We are the consciousness of the island universe. Scientists understand this connection through the laws of thermodynamics. They know that energy cannot be created or destroyed, only transformed. The light of Andromeda is not gone once it reaches us. It is merely changed. It becomes part of the thermal history of our planet. It becomes the inspiration for a thought. It becomes the catalyst for a dream. In the infinite ending, we realize that every moment of our lives is a recipient of ancient cosmic energy. We are the destination for a 1 trillion-year-old journey. This makes every quiet breath a significant event in the history of the universe. And for now, that uncertainty is simply part of the picture. It doesn't need to be resolved tonight. We don't need to know the final temperature of the universe or the exact number of black holes that will remain in the dark era. Those are questions for the morning. Tonight, we are concerned only with the continuity. We are concerned with the fact that the light is still traveling, the galaxies are still drawing closer, and the story is still unfolding. The infinite ending is a loop-safe state. It is a realization that we can begin again at any moment. Every end is a transition, and every transition is an opportunity to find a new kind of stillness. The universe is far, but it is home. It is home because it is the only place there is. It is home because it is where you were born, where you live, and where you will eventually return to the stars. The scale of Andromeda is just a measure of how large your home really is. It is a house with 1 trillion rooms, and you are currently resting in one of its most comfortable corners. The windows are open to the night, and the light of the neighbors is shining in, ancient and steady. And so the universe continues, expanding, cooling, changing slowly, quietly, endlessly. You don't need to stay awake for this part. The universe will still be here, moving gently forward, long after this moment passes. The light that began its journey 2.5 million years ago has finally found its rest. And as that light settles, so do you. The journey is complete, and yet it is always unfolding. The scale is vast, and yet it is intimate. The universe is far, and yet it is home. You are safe. You are part of the continuity. You are a star in your own right, burning with the quiet fire of consciousness in a universe that is mostly shadow. But the shadow is not the enemy. It is the rest. It is the peace between the pulses of light. It is the infinite ending. And somewhere within all of this, we can begin again by starting with something familiar. The room is quiet. The air is still. The galaxy is turning. You are home. Good night. Imagine climbing a ladder where every new rung makes the previous one look microscopic. We begin with Earth, a world that seems enormous when you are standing on its surface, with oceans covering 71% of its face and mountains rising miles into the sky. But as we zoom out, Earth begins to shrink, not physically, but in significance. It stops being everything and becomes just one thing among many. Compared to the solar system, Earth is a speck. Compared to the galaxy, the solar system is a speck. And compared to the largest structures in the cosmos, even entire galaxies are like dust. To understand this ladder, we must first appreciate the rung we are currently standing on. To an early human, the Earth wasn't a planet. It was the floor of the universe. If you were to stand in the middle of a vast, flat plain, the horizon is only about 5 kilometers away. That was the limit of your world. Beyond that was mystery. Even today, with all our technology, the sheer physical bulk of the Earth is staggering. If you were to take a commercial flight from New York to Singapore, you would spend nearly 19 hours in the air, traveling at 500 miles per hour, and you would still only have covered a fraction of the planet's circumference. We perceive the Earth as a giant because, relative to our bodies, it is. We are 6-foot creatures living on a 12,000-kilometer sphere. But now, we take the first step up the ladder. We move from the Earth to its neighborhood, the inner solar system. As we pull away, the massive continents and vast oceans we just described begin to blur. At a distance of about 1 million kilometers, the Earth no longer looks like a world. It looks like a marble, and right next to it, relatively speaking, is the Moon. We often see diagrams of the Earth and Moon close together, but the reality is much emptier. You could fit every other planet in our solar system, Jupiter, Saturn, Mars, Venus, all of them into the space between the Earth and the Moon, and you'd still have room to spare. This is our first lesson in cosmic scale. Space is mostly empty. Even the crowded parts are defined by the gaps, not the objects. As we continue to climb, we reach the rung of the gas giants. This is where Earth's ego takes its first major blow. Jupiter is so large that 1,300 Earths could fit inside it. If Earth were the size of a grape, Jupiter would be the size of a basketball. Saturn with its magnificent rings, isn't much smaller. These are worlds made of gas and liquid, with pressures so intense they turn hydrogen into metal. When you look at Jupiter's Great Red Spot, a storm that has been raging for centuries, you are looking at a vortex that is wider than our entire planet. On this rung of the ladder, Earth has transitioned from the world to a minor rocky outpost. But the ladder doesn't stop at the planets. The next rung belongs to the Sunday. Our star is a yellow dwarf, a relatively average star, yet it contains 99.8% of all the mass in the solar system. You could fit 1 million Earths inside the Sunday. If the Sun were the size of a front door, the Earth would be the size of a nickel. At this stage, the scale of the planets, even Jupiter, starts to look trivial. The Sun's gravity is the anchor that holds everything together, reaching out billions of miles to the frozen edges of the Kuiper Belt. Yet, even the Sun is just a starting point. We climb higher, and now we are looking at the interstellar neighborhood. We are no longer measuring in miles or kilometers. We are measuring in the distance light travels in a year. The Sun, which seemed so dominant, begins to shrink into a tiny point of light. It joins a crowd of other stars, Alpha Centauri, Sirius, Vega. We begin to realize that our Sun is just one of 200 to 400 billion stars in the Milky Way. On this rung, the entire solar system, everything from the Sun to the furthest comet in the Oort cloud, is smaller than a single pixel on a high-definition screen. We have reached a level where the individual planets are literally too small to see. Now we reach the rung of the galaxy. The Milky Way is a barred spiral, a vast disk of stars, gas, and dust spinning through the void. It is 100,000 light-years across. To get a sense of this scale, if our entire solar system out to Neptune was the size of a white blood cell, the Milky Way would be the size of the continental United States. We are tucked away in one of the spiral arms, about 26,000 light-years from the center. At the heart of this massive structure is Sagittarius A*, a supermassive black hole 4 million times the mass of the Sunday. On this rung, the world we started with is not just a speck, it is an invisible ghost, an infinitesimal part of a much larger organism. But the ladder keeps going. We move to the local group. This is a collection of about 50 galaxies, including our own and our larger neighbor, Andromeda. These galaxies are bound together by gravity, dancing around each other in a dark cosmic ballet. The distance between the Milky Way and Andromeda is 2.5 million light-years. On this rung, even the 100,000 light-year span of our galaxy starts to look manageable. We are seeing galaxies not as vast expanses of stars, but as individual units, islands of light in a sea of nothingness. We climb further, reaching the rung of galaxy clusters and superclusters. We encounter the Virgo supercluster, which contains thousands of galaxies. And then we see the Laniakea supercluster, a structure so vast it defines our place in the local universe. Laniakea, which means immeasurable heaven in Hawaiian, is 500 million light-years across. It contains the mass of 100 quadrillion suns. On this rung, the Milky Way is just a tiny spark on one of the outer branches of a massive, glowing celestial tree. The ladder of scales has now taken us to a point where distance has become a concept that our brains can only process through mathematics. But there is one more rung we've discovered recently, the rung of the great filaments. These are the largest structures ever found in the universe. We are talking about things like the Hercules Corona Borealis Great Wall. This is a filament of galaxies that spans 10 billion light-years. That is about 10% of the entire observable universe. It is a structure so gargantuan that it challenges our fundamental understanding of how the universe began. According to the cosmological principle, the universe should be smooth and uniform on such large scales, yet here is a wall of matter that defies that smoothness. On this final rung, we aren't just looking at stars or galaxies, we are looking at the cosmic web, the very skeleton of reality. Think back to where we started, a 5-kilometer walk to the horizon. We have climbed from that walk to a structure 10 billion light-years long. The ratio between a human stride and the Great Wall is almost too large to write down in zeros. This is the ladder of scales. It is a journey of systematic humiliation for the human ego, but it is also a journey of profound discovery. Every time we move up a rung, we lose something and we gain something. We lose the feeling of being the center of the universe. We lose the idea that our planet is a massive, indestructible fortress. But we gain a perspective that no other known species possesses. We gain the ability to see the long view. We learn that the universe isn't just a place where things happen. It is a structured, evolving, and terrifyingly beautiful hierarchy. This ladder also teaches us about the nature of size. Size is entirely contextual. To a mountain, a human is nothing. To the earth, a mountain is a wrinkle. To the sun, the earth is a pebble. To the galaxy, the sun is a grain of sand. And to the cosmic web, the galaxy is a puff of smoke. When we talk about the largest object ever found, like the Quipu or IC 1101, we aren't just talking about big things. We are talking about the limits of structure itself. We are asking, how much matter can gravity hold together before the expansion of the universe pulls it apart? As you use this segment in your stories, remember that the ladder of scales is the ultimate narrative tool. It allows you to move the audience from the intimate to the infinite. It reminds the viewer that while their problems feel world-sized, the world itself is speck-sized. This contrast is where the awe comes from. It's the tension between our tiny, fragile lives and the massive, ancient structures that surround us. We are creatures of the first rung, yet we have built telescopes and theories that allow us to see the top of the ladder. We may never physically leave our neighborhood, but mentally, we have already conquered the Great Wall. We have mapped the Laniakea supercluster from the surface of a small, rocky planet orbiting an ordinary star. So, when you look at the night sky, try to see the rungs. Don't just see points of light. See the depth, unmer. See the moon just above us, the planets further out, the stars beyond them, and the faint glow of distant galaxies beyond those. Understand that you are standing on the bottom step of a ladder that goes on forever. The horizon isn't 5 kilometers away, it's 46 billion light-years away in every direction. And the fact that you can even conceive of that distance means that while you are physically small, your mind is as vast as the ladder itself. We have seen the scale, we have felt the shrink. Now, in the next segments, we will look at the bridge that connects these rungs, light itself. We will see how we cross these distances not with rockets, but with our eyes. The ladder is tall, but the view from the top is spectacular. To climb this ladder of scales is to participate in a systematic dismantling of our own intuition. We start with the Earth, our human anchor, where the horizon is a mere 5 kilometers away. On this first rung, we are masters of our domain. We measure the world in footsteps and hours. But the moment we look up and contemplate the lunar gap, that 384,400 kilometer chasm, we realize that our biological yardsticks are already starting to snap. If you were to drive a car at highway speeds toward the moon, it would take you 6 months of non-stop travel. If you chose to walk, you would need 9 years of your life. Already, on just the second rung of the ladder, the human scale has become a burden rather than a tool. As we ascend to the solar anchor, the numbers don't just grow, they transform. The Sun is 150 million kilometers away, 1 astronomical unit, AU. To walk this distance would take 3,500 years. We are now dealing with scales where entire civilizations could rise and fall in the time it takes to cross the gap. This is why we must transition to the most fundamental constant in the universe: light. Light is the only thing fast enough to act as a bridge across these gulfs. It travels at 300,000 kilometers per second. It can circle the Earth 7 times in a single heartbeat. Yet, even light takes 8 minutes to reach us from the Sunday. When we look at the Sun, we are not seeing it as it is now, but as it was nearly 9 minutes ago. We have begun our transition from space travelers to time travelers. The ladder takes us further into the interstellar neighborhood. Here, the Sun, a star that could hold 1 million Earths, shrinks into a tiny, flickering point of light among billions of others. We find ourselves in the Milky Way, a barred spiral galaxy, 100,000 light-years across. To grasp this, imagine the entire Earth is the size of a single grain of sand. In this scale, the Milky Way would be the size of the entire United States. Every star you see in the night sky is just a local neighbor in our small corner of this vast continental structure. We are tucked away in the Orion Arm, 26,000 light-years from a supermassive black hole that anchors our galaxy. On this rung, the individual planets are no longer visible. They are ghosts lost in the glare of 200 billion suns. But the ladder does not end at the edge of our galaxy. We reach the rung of the local group, a collection of 50 galaxies bound together by gravity. Our sister galaxy, Andromeda, sits 2.5 million light-years away. If the Milky Way is a city of light, the local group is a small cluster of towns separated by vast, dark countrysides. Beyond this lies the Virgo supercluster, a massive assembly of thousands of galaxies. And beyond that, the Laniakea supercluster, a structure so gargantuan it spans 500 million light-years. Laniakea, meaning immeasurable heaven, is a web of light where galaxies flow like water toward a gravitational center called the Great Attractor. As we reach the highest rungs, we encounter the defiant anomalies, structures that shouldn't exist. We find the Hercules Corona Borealis Great Wall, a filament of galaxies spanning 10 billion light-years. This structure represents 10% of the entire observable universe. Its very existence challenges the cosmological principle, which assumes the universe should be smooth and uniform on large scales. This wall is a giant knot in the fabric of space-time, a testament to the fact that the ladder of scales still has rungs we don't fully understand. We see giant circles in the cosmic microwave background and cold spots that hint at collisions with other universes or remnants from before the Big Bang itself. We also witness the monster galaxies like IC 1101. While our Milky Way is 100,000 light-years wide, IC 1101 is 6 million light-years across. It is an elliptical giant that has grown by devouring thousands of smaller galaxies over billions of years. If you placed IC 1101 where the Milky Way is today, it would swallow up Andromeda and most of our local group. It is a graveyard of stars, a terminal point in the evolution of galactic structures. At this scale, even the light that bridges the rungs takes millions of years to cross from one side of a single galaxy to the other. The ladder of scales reveals a universe that is a system of systems. Atoms form molecules. Molecules form dust. Dust forms planets. Planets orbit stars. Stars cluster into galaxies. And galaxies weave into the cosmic web. For 6 years, this object remained a ghost in the machine. It appeared in images taken between 2014 and 2019. But it was so far away, nearly as far as Neptune, that it looked like nothing more than a static pinprick of light. It took the dedicated work of Pedro Bernardinelli and Gary Bernstein to apply sophisticated algorithms to this massive data set, tracking the subtle shift of that single point against the background of fixed stars. Think of the patience required for such a task. It is the digital equivalent of watching a glacier move from a mile away. You cannot see the motion in real time. You can only see where it was and where it has arrived. When the calculations were finally completed, the scientific community felt a collective sense of quiet awe. Most comets that venture into the inner solar system are the size of small villages, perhaps 2 or 3 miles across. When a 10-mile wide comet appears, it is a once-in-a-generation event. But 85 miles, that is a measurement that feels almost illegal in the context of cometary science. It shouldn't be there, and yet, there it is, a dark titan emerging from the gloom. If you were to drive a car around the circumference of this comet's nucleus, it would be a journey of over 260 miles. You would be driving for hours through a landscape of frozen methane, ancient dust, and water ice that hasn't felt the warmth of a sun in millions of years. The discovery was not a eureka moment of flashing lights and sirens. It was a slow dawning of reality. The data showed that this object wasn't just large, it was exceptionally fresh. Most comets we see have been baked by the sun many times, their surfaces scarred and depleted of their original gases. But Bernardinelli-Bernstein is a traveler from the deep freeze. It is arriving with its primordial coat intact. This makes it a scientific treasure, a pristine sample of the ingredients that cooked in the solar nebula billions of years ago. We are looking at a giant that has been kept in the back of the freezer since the very first day the kitchen opened. As we sit with this thought, we might wonder what else is out there, still hidden in the data. The universe is a very large place, and our eyes, even our digital ones, are very small. We only found this giant because it was large enough to reflect a tiny bit of sunlight back toward our telescopes. There may be others, even larger, still drifting in the shadows of the Kuiper belt or the inner Oort cloud, waiting for their turn to be noticed. But there is no hurry to find them. The universe is patient, and the data will be there when we are ready to look. The mystery of its composition remains one of those beautiful, open questions. Is it a rubble pile, a collection of boulders and dust, barely holding on to one another in a delicate gravitational hug? Or is it a solid, crystalline heart of ice, as hard as granite and as cold as the void itself? We don't know yet, and that is okay. We can visualize both possibilities as we drift towards sleep. We can imagine the jagged cliffs of ice or the soft, powdery slopes of cosmic dust. Both are equally silent. Both are equally ancient. In the history of astronomy, we have often been surprised by the scale of things. We once thought the Earth was the center of everything. Then we thought the Sun was the center. Then we realized our galaxy was just one of billions. Every discovery of a giant like this comet is a gentle reminder that we are still in the early chapters of the book. We are still learning the true dimensions of our own backyard. As we move outward in our minds, past the orbit of Neptune and into the scattering of the outer reaches, we can feel the comfort of that vastness. There is so much room for these giants to roam. There is so much space for them to exist without ever crowding us. The comet is currently on its way in, but in is a relative term. It will never get closer to the Sun than the orbit of Saturn. It is keeping its distance, a polite visitor that doesn't want to intrude. It will flare up, its coma will grow, and it will eventually become a bright target for our most powerful telescopes, but it will remain a distant, silent observer. We have years to watch it. We have decades to study it. There is no urgency in the cosmos. Everything happens in its own time, governed by the elegant, slow-moving laws of orbital mechanics. As we conclude this first loop of scale, let your mind settle on that 85-mile-wide nucleus. Visualize it as a dark, silent island in a sea of nothingness. It is moving toward us, but so slowly that it will take another decade just to reach its closest point. It has all the time in the universe, and for tonight, so do you. You are part of a world that can find such things, that can look into the dark and see the giants moving there. It is a quiet, contemplative thought to carry with you. With that in mind, let's move outward once more, to an even larger scale. One level beyond what we just explored lies the moment of discovery. Scientists understand the scale of the universe by observing minute changes in light over long periods of time. In 2014, while looking at data from the Dark Energy Survey, astronomers noticed a tiny point of light. It was moving, but so slowly that it took years of observation to realize it wasn't a distant star or a galaxy. What we know so far suggests that this object, C 2014 UN 271, is roughly 85 miles across. To put that in perspective, if you were to place this comet on the ground, it would cover the entire state of Rhode Island and still have room for a few extra towns. But even with everything we've learned, there are still things we don't fully understand. We see its size, but we do not yet know its exact composition. Is it a solid block of ancient ice, or a loose collection of dust held together by the faintest hint of gravity? Not because we're missing something urgent, but because the universe moves slowly over immense spans of time. And for now, that uncertainty is simply part of the picture. It doesn't need to be resolved tonight. With that in mind, let's move outward once more to an even larger scale. To appreciate the discovery of Bernardinelli Bernstein, we have to look into the way we perceive the dark. In our daily lives, discovery is often a sharp, sudden moment, a flash of a camera, the turning of a page, or the finding of a lost set of keys. But in the deep reaches of the solar system, discovery is a slow accumulation of evidence. It is a patient gathering of photons, one by one, over years of silent observation. The Dark Energy Survey was never designed to find a comet. Its primary focus was the most distant structures in the cosmos, galaxies and clusters billions of light years away, expanding into the void. But as our telescopes peer into the furthest depths of the past, they occasionally catch a glimpse of the present drifting much closer to home. It is like looking through a window at a distant mountain and noticing a tiny, slow-moving snowflake right on the glass. The digital eye of the dark energy camera is a marvel of human engineering, yet it can only see what it is programmed to recognize. For years, the data containing this giant comet sat in digital archives, a silent point of light among hundreds of millions of others. It took the dedicated work of human minds, coupled with the tireless processing of algorithms, to see the pattern. They weren't looking for a record breaker. They were looking for anything that moved against the backdrop of the fixed stars. Think of the quiet persistence of such a search. It is the work of years, not minutes. It is a process of subtraction, removing everything that stays still until only the wanderers remain. When they finally isolated C, 2014 UN 271, they realized they weren't looking at a faint star at all, but a massive object only a few billion miles away. The scale of 85 miles across is difficult for us to hold in our minds without a sense of quiet wonder. In the world of comets, anything over 10 miles is considered a behemoth. To find something 10 times that diameter is to find a visitor that defies the standard rules of its species. If you were to walk across this comet, as we imagined earlier, you would be traveling through a landscape that is physically larger than many mountain ranges on Earth. It is a world unto itself, a dark, frozen island that has its own gravity, its own topology, and its own deep internal history. We see its silhouette, but we do not see its heart. This is the mystery of the discovery. We have found the giant, but we are only just beginning to learn its name. Historically, the discovery of a new comet was a task for the naked eye or the small telescope, a hobby for the patient watcher in a backyard. But as our technology has expanded, the backyard has become the entire solar system. We are now able to find these objects while they are still in the deep freeze of the outer planets. When Bernardinelli Bernstein was first spotted, it was as far away as Neptune, drifting in a region where the sun is just a particularly bright star. Most comets are invisible at that distance. They are too small and too dark to reflect enough light. But this one was different. It was so large that it made its presence known long before it ever felt the warmth of the inner solar system. It was a giant calling out from the shadows, a sentinel that refused to be ignored. What we know so far suggests that this object is a pristine traveler. This is a term astronomers use for something that has never been cooked by the sunday. Every time a comet passes near the sun, it loses layers of its history. Its ice sublimates, its dust blows away, and its surface is scarred by the heat. But because this comet has such an immense orbit, lasting millions of years, it has spent almost its entire existence in the absolute zero of the Oort cloud. It is a time capsule from the very first days of our solar system. The discovery of such an object is like finding a perfectly preserved letter from a distant ancestor, written in a language that predates our own. It is a gift of information, delivered by gravity at a pace that respects our need for quiet. But even with everything we've learned, there are still things we don't fully understand about how it came to be in its current path. The universe is a vast field of motion, and every object in it is responding to a complex web of gravitational tugs. Was this comet nudged by a passing star 3 million years ago? Or was it moved by the subtle galactic tide, the gravitational breathing of the Milky Way itself? We see the result, the 8.5-mile wide nucleus falling slowly toward the Sun, but the cause remains an open question. This is the mild mystery that keeps curiosity alive without creating tension. It is a puzzle that stretches across light years and eons, and we are content to let it remain a puzzle for tonight. The uncertainty of its composition is another gentle thought to carry with us towards sleep. We often want to categorize things, to say, it is this, or it is that, but Bernardinelli Bernstein sits in a category of its own. It is larger than most asteroids, yet it behaves like a comet. It is a mountain of ice, yet it is as dark as coal. Scientists debate whether it is a solid, monolithic block or a loose rubble pile held together by a gravitational whisper. You can imagine both possibilities. You can visualize a solid, crystalline heart of ancient ice, as hard as diamond. Or you can visualize a soft, porous collection of dust and boulders, like a cloud that has decided to take a physical form. Neither answer changes the beauty of the object. Both are simply ways for us to try and understand the scale of the giant. As we move outward in our perspective, the discovery of the comet becomes a discovery of ourselves. It shows us that we are capable of looking into the dark and finding the hidden structures of our home. It shows us that we have the patience to watch a single point of light for 6 years just to see it move. This capacity for patient observation is a calming quality. It reminds us that we don't have to solve everything immediately. We can gather data, we can wait, and we can allow the truth to reveal itself in its own time. The comet is moving at its own pace, and we are watching at our own pace. There is no conflict in this relationship. There is only the steady, shared progression of time. Consider the 85 miles once more. It is a number, but it is also a landscape. On Earth, 85 miles is the distance between 2 distant cities. It is a journey that would take a bird an entire day to fly. On the comet, that distance is occupied by a single, silent presence. There are no roads there, no lights, no sounds. There is only the dark, ancient surface and the distant glitter of the stars. The discovery of this landscape is a reminder that the universe is far more substantial than we often imagine. It is not just empty space. It is filled with these massive, enduring landmarks. They are the fixed points in our moving neighborhood. The fact that this discovery happened now, in our lifetime, is a quiet hook of wonder. For millions of years, this comet was drifting in the dark, unseen and unknown. It passed the orbits of the outer planets in silence. But as it approached the inner realms, we were here to greet it with our digital eyes. It is a brief intersection of 2 very different histories, the 3 and 5 million year history of the comet and the few 1,000-year history of human astronomy. We are witnessing a moment that will not be repeated for another 3 million years. There is a gentleness in this timing. We don't have to do anything about it. We simply have to be here to acknowledge it. As the mind begins to drift, let the numbers and the facts start to soften. The 85 miles becomes just a vast, comfortable distance. The 2014 discovery becomes just a moment of quiet recognition in the past. The algorithms and the telescopes fade into the background. What remains is the image of the giant mountain of ice moving through the dark with a calm and inevitable momentum. It has been found, but it is still free. It has been measured, but it is still a mystery. It is a sentinel at the edge of the world, and we are the quiet observers, safe in the knowledge that the universe is much larger and much more stable than we could have ever dreamed. The uncertainty is simply part of the picture. It doesn't need to be resolved tonight. We can accept the unknown as a comfortable neighbor. We can live with the mystery of the comet's heart, just as we live with the mystery of our own dreams. Both are vast, both are ancient, and both are unfolding exactly as they should. The discovery is not an end point, it is a gateway. It is an invitation to look further, to move outward, and to embrace the scale of the cosmos without fear. With that in mind, let's move outward once more to an even larger scale. This delay is the first layer of the deep drift. It is a reminder that the universe has a built-in latency. We are always looking at the past. The further we look, the deeper into history we descend. This challenges how we think about the present moment. Is there even such a thing as now for the entire universe? Plus, or is now just a local experience, limited by the speed at which information can travel? Scientists have spent centuries debating this, and yet the mystery remains as calm and quiet as the stars themselves. Consider the Voyager spacecraft, the furthest human-made object. It has been traveling for decades, moving faster than any bullet ever fired. Yet, if we were to send a light signal to Voyager today, it would reach the craft in less than a day. Light covers in hours what it takes our best technology half a century to achieve. This is the scale of the marathon light is running. It is a constant, tireless sprint across a stadium that has no walls. But even with everything we've learned, there are still things we don't fully understand. We don't know why light moves at this specific speed. Why 300,000 kilometers per second? Why not more? Why not less? It is one of the fundamental constants of nature, a number woven into the fabric of space-time itself. It doesn't need to be explained or justified, it simply is. And for now, that uncertainty is simply part of the picture. It doesn't need to be resolved tonight. As we settle into this scale, let your mind rest on the idea of the light second. It is a distance of 300,000 kilometers, nearly 10 times the circumference of the Earth. It is a massive distance, yet it is only 1/62nd of a light minute, and a light minute is but a tiny fraction of a light year. We are building a tower of scale, and the light second is just the foundation. Imagine you are a traveler made of light. You leave the Earth behind. In 1 second, you have passed the moon. In 2 minutes, you are passing the inner planets. In 8 minutes, you reach the Sunday. 12. You are moving so fast that the planets appear like stationary marbles in a vast, dark room. But as you look ahead, you realize the room is much larger than you thought. The next nearest object is not minutes away. It is not hours away. It is years away. This is where the true scale of the light year begins to reveal itself. To cover the distance of 1 light year, you would have to maintain this 300,000 kilometer per second pace for 31,536,000 seconds. Every second, another 300,000 kilometers. Every hour, another billion kilometers. Day after day, month after month, for an entire year. By the end of that journey, you would have traveled nearly 9.5 trillion kilometers. That is 1 light year. If we tried to use kilometers to describe the distance to the nearest star, we would be talking about 40 trillion kilometers. The numbers become a noise, a static that our brains cannot process. But 4.2 light years is something we can hold. It is a duration. It is the length of a high school education. It is the time it takes for a toddler to become a student. It gives the distance a human heartbeat. As you drift closer to sleep, imagine these beams of light crossing the void. They are silent. They do not carry heat across the vacuum. They are just pure information, pure energy, traveling through a cold, dark expanse that is mostly empty. The universe is not a crowded place. It is a series of very small lights, separated by very large silences. The light year is the measurement of that silence. We are moving outward now, leaving the realm of the light second and the light minute. We are entering the space where the light year becomes the only sensible way to speak. It is a transition that feels inevitable, like the slow turning of the tide. You don't need to do anything. You don't need to solve any equations. Just let the speed of light become the background rhythm of your thoughts. The universe moves slowly over immense spans of time, even when it is moving at the speed of light. And for now, that uncertainty, that vastness, is simply part of the picture. It is a safe place to be. You are here, in your bed, while the light is out there, doing the work of bridging the distances for you. With that in mind, let's move outward once more, to an even larger scale, beyond the speed of light, beyond the inner solar system, and toward the gaps that define our place in the galaxy. We are now entering the territory where the human-scale anchor no longer just slips. It vanishes entirely. To understand the transition from the speed of light to the distance of a light year, we have to look at the sheer, overwhelming volume of the vacuum. Imagine for a moment that we could drain the universe of all its stars, all its planets, and all its dust. What remains is the canvas upon which light performs its marathon. This canvas is so vast that even at 300,000 kilometers per second, light is not a flash. It is a slow, steady pulse, a lonely traveler crossing a desert that has no markers. As we drift further from the sun, we begin to encounter the true nothingness that defines the cosmos. In our daily lives, empty usually means a room without furniture or a glass without water. But in the space between the stars, empty is a profound, almost mathematical purity. There are regions of space where you could travel for a light year, 9.5 trillion kilometers, and encounter fewer atoms than you would find in a single grain of sand. This is the low-density reality that light must navigate. When we say that a star is 4 light years away, we aren't just saying it's far. We are saying there is a 4-year-long gap of absolute, freezing silence between us and that distant fire. Scientists understand this by calculating the look-back time. This is a concept that acts as a verbal dissolve between the present and the past. Because light has a fixed speed, Every distance in the universe is also a measurement of history. If you look at an object that is 1 light year away, you are seeing it exactly as it appeared 365 days ago. You are not looking across space so much as you are looking through time. This challenges how we think about the reality of the now. In the deep drift of the galaxy, there is no simultaneous moment. Each star exists in its own bubble of time, sending out messages that will not be received for years, decades, or centuries. Consider the sheer scale of a single light year once more. To visualize 9.5 trillion kilometers, imagine the distance from the Earth to the Sun, that 8-minute journey we discussed earlier. Now, take that distance and stack it end to end 63,000 times. That is 1 light year. It is a distance so long that if you were to represent the Earth-Sun distance as 1 inch, a single light year would still be over a mile long. And remember, the nearest star is over 4 of those miles away. This is the scale expansion that begins to blow the human mind. We aren't just moving away from home, we are moving into a geography that refuses to be tamed by our standard maps. What makes this strange is not what we see, but what we don't understand about the nature of the vacuum itself. Astronomers didn't expect to find that space is expanding, a discovery that adds a layer of quiet complexity to our journey. As light travels its 9.5 trillion kilometers every year, the space it is traveling through is itself stretching, very slightly, every second. It's as if the marathon track is growing longer while the runner is mid-stride. This doesn't affect our local neighborhood much, but over the immense periods of time that light spends in transit, it changes the very color and energy of the light itself. It is a slow, rhythmic stretching of reality that happens without hurry and without end. As you listen, let the rhythm of these numbers settle into your breathing. Ow, 300,000 kilometers per second. 18 million kilometers per minute. 1 billion kilometers per hour. These are not numbers to be feared or solved. They are simply the heartbeat of the vacuum. They represent the tireless work of the universe, moving energy from one place to another across the dark. You are safe in the knowledge that this process is constant. The speed of light does not falter. It does not tire. It is the one thing in the universe that remains exactly the same, no matter where you are or how fast you are moving. And for now, that uncertainty about why the universe is so large and why we are separated by such vast gulfs of time is simply part of the picture. It doesn't need to be resolved tonight. We can accept the silence of the light years. We can accept that the stars we see tonight are ghosts of their past selves, and that our own light is currently traveling outward, a faint signal crossing the void to reach eyes that won't exist for another million years. This is the cosmic continuity, the realization that we are all part of a single, slow-moving story. Imagine you are a photon that has just finished its first year of travel. You have covered 1 light year. You look back, and the sun is no longer a blinding disk. It has shrunk to a bright, steady point of light, one star among many. You look forward, and the destination still looks impossibly far away. There is no wind in space, no sound, and no resistance. You are simply falling through the dark at the maximum possible speed, a tiny spark of information in a cathedral of shadow. This is the essence of the scale loop. We expand our view, we realize the vastness, we accept the mystery, and then we move outward once more. To understand that, we need to step back and look at the human scale perspective one last time before it disappears completely. On Earth, we think of a year as a long time. It is a cycle of seasons, a series of memories. But to the universe, a year is just the time it takes for light to cross a tiny fraction of a galaxy. When we combine the two, the human year and the cosmic speed, we get the light year. It is our way of speaking the universe's language using our own alphabet. It is a gentle humility, acknowledging that while we may be small, we have found a way to measure the infinite. As we conclude this first scale loop, let the image of the light marathon carry you toward a deeper state of relaxation. The light is moving, but you are still. The universe is vast, but you are warm and safe. The distances are mind-blowing, but they are also orderly and predictable. There is a peace in the precision of the speed of light. It is the ultimate clock, ticking away the seconds across the trillions of kilometers. And for now, that uncertainty is simply part of the picture. It doesn't need to be resolved tonight. We have reached the first marker on our journey. We have looked at the speed, we have looked at the distance, and we have accepted the delay. We are now ready to leave the inner solar system behind for good and look at the objects that wait for us in the deep, quiet dark of the interstellar gaps. With that in mind, let's move outward once more, to an even larger scale. Now, let's slowly expand outward. One level beyond the speed of light lies our own neighborhood, the solar system. To truly grasp the weight of a light year, we must first look at the smaller, more intimate delays that happen right here in our own backyard. We often think of our solar system as a single cohesive unit, a family of planets huddling around a central fire. But even within this family, the distances are so great that light, the fastest messenger in existence, begins to show the first signs of its struggle against the void. This is where we first encounter the lag of reality, a gentle reminder that nothing in the universe happens in a true, synchronized now. What we know so far suggests that the moon is about 384,000 kilometers away. To our human scale perspective, this is a massive distance, a journey that took the Apollo astronauts 3 days of intense travel to complete. But for light, this gap is merely a brief pause. When you look up at the moon tonight, you are seeing it as it was 1.3 seconds ago. It takes that long for the sunlight bouncing off the lunar surface to reach your eyes. This is the lunar delay. It is a small, almost imperceptible gap, but it is the first crack in the illusion of an instantaneous universe. If a large boulder were to roll across the lunar plains, or if a meteorite were to strike the surface, you would remain unaware of it for over a second. You are always watching a slightly delayed broadcast of our nearest neighbor. As we move past the moon, the seconds begin to turn into minutes. The sun, the very engine of our lives, sits much further away, about 150 million kilometers. This is the distance astronomers call an astronomical unit, or 1 AU. It is the gold standard for measuring our local neighborhood. Yet, even light needs time to cross this threshold. It takes 8 minutes and 20 seconds for a photon to travel from the surface of the sun to the Earth. If the sun were to suddenly go out, we wouldn't know it for 8 minutes. We would continue to live in its warmth and light, unaware that its source was already gone. Children would keep playing in the park, solar panels would continue to generate power, and the world would remain bright, all while the sun itself was already dark. We would continue to orbit a ghost of a star for those final 8 minutes. This comparison isn't perfect, but it gives us a calm place to begin. It shows us that even the most fundamental things in our lives, the very light of day, are subject to the patient laws of cosmic distance. Scientists understand these delays by observing the movement of the planets. When we send rovers to Mars, for instance, we cannot drive them in real time with a joystick. Depending on where Mars and Earth are in their orbits, the light delay can be anywhere from 3 to 22 minutes. If a rover is heading toward a cliff, the signal telling it to stop takes minutes to arrive, and the confirmation that it has stopped takes another few minutes to return. We are forced to communicate with the solar system through a veil of time. We are always talking to the past version of the planets, and they are always responding to a past version of us. But even with everything we've learned, there are still things we don't fully understand about how these distances affect our perception. Not because we're missing something urgent, but because the universe moves slowly over immense spans of time. To understand the scale, imagine you are standing in a vast, dark forest. You have a friend standing a few hundred yards away with a bell. When they ring the bell, you hear the sound a moment later because sound travels slowly. In the solar system, light is like that bell. It is incredibly fast, but the forest is so big that the sound of the light still takes time to reach your ears. As we drift further out to the gas giants like Jupiter and Saturn, the minutes turn into hours. When we look at Jupiter, we are seeing it as it was 40 minutes ago. When we look at Saturn, the light has been traveling for over an hour. If you were to watch the beautiful rings of Saturn through a telescope, you are seeing them not as they are in this moment, but as they were while you were perhaps finishing your dinner or starting this very script. The universe is a series of nested time capsules, each one holding a slightly older version of reality. This brings us to a quiet realization. We are never truly in the present when we look at the sky. We are observers of history. The light minutes that separate us from the planets are the first steps toward the light years that separate us from the stars. It is a gradual expansion of the now until it becomes so thin that it disappears entirely. In our daily lives, we measure time in seconds, minutes, and hours. But in the solar system, we begin to see that time and distance are the same thing. 1 AU is not just 150 million kilometers, it is also 8 light minutes. The distance is the time. Astronomers didn't expect the solar system to feel so empty, yet the gaps between the planets are far larger than the planets themselves. If you were to shrink the sun to the size of a grapefruit, the Earth would be a tiny grain of sand about 50 feet away. Jupiter would be a cherry about 2 blocks away, and the nearest star, that grapefruit, would be thousands of miles away. This is why we need the light year. Kilometers are too small to bridge the gaps between the fruits in our cosmic orchard. When we think about distance, we often imagine it in human terms. Distances we can walk, time we can measure in years, objects we can see with our own eyes. Our brains are beautifully adapted for the world we inhabit, a world of rolling hills, city blocks, and horizons that seem far away but are actually quite intimate. When you plan a trip to see a friend in another town, you think of it in hours spent in a car. When you go for a morning stroll, you think of it in the rhythm of your footsteps and the gentle passage of minutes. This is our anchor. It is a safe, predictable way of measuring the reality around us. For example, consider the simple act of walking. A kilometer is a distance most of us can visualize clearly. It is roughly 10 to 12 minutes of steady movement. If you were to set out on a walk today and continue until the sunset, you might cover 30 or 40 kilometers. You would feel that distance in your muscles. You would see the landscape change slowly from one neighborhood to the next. This is a scale that makes sense. It is tangible. If you were to walk across an entire continent, it would take you months of dedicated effort, a journey that would define a significant portion of your year. But as we begin to look upward, these human measurements start to feel a bit like trying to measure the depth of the ocean with a teaspoon. To understand a light year, we first have to realize just how much room there is in our own immediate surroundings. Let's look at our own world, the Earth. It is approximately 12,700 kilometers in diameter. To us, that is massive. It contains every ocean, every mountain range, and every city ever built. If you were to get into a commercial airplane and fly non-stop around the equator, it would take you about 2 full days of constant travel. That feels like a long time. It is a distance that commands respect in our minds. Yet, compared to the distances we are about to discuss, the Earth is effectively a single point. Even the gap between us and our closest neighbor, the Moon, begins to strain our human-scale perspective. The Moon is about 384,000 kilometers away. That is roughly 30 Earths laid side by side. If you could somehow drive a car to the Moon at highway speeds, it would take you about 6 months of driving 24 hours a day without a single stop for gas or rest. 6 months. That is half a year of your life spent just crossing the empty space between us and the nearest object in the sky. This comparison isn't perfect, but it gives us a calm place to begin. It reminds us that even near things in space are incredibly far by human standards. And yet, light crosses that same 384,000 kilometer gap in just over 1 second. 1 second. In the time it takes you to draw a single breath, a beam of light has already completed the journey that would take you half a year to drive. This is the first hint of the staggering efficiency of light, and the first clue as to why we need a new way to measure the universe. As we sit here, grounded and safe, we can begin to appreciate the stillness of our own scale. We live in the realm of centimeters, meters, and kilometers. We live in the world of the now, where we assume that when we see something, it is happening exactly as we perceive it. If a friend waves at you from across the street, you see them instantly. There is no lag, no delay that our senses can detect. But as we step further out, we will find that the universe has a speed limit, and that limit creates a bridge between distance and time. Imagine for a moment a vast, empty field. If you stand on one side and a friend stands on the other, and you both hold powerful flashlights, the light from their lamp seems to hit your eyes the exact moment they click the switch. On this scale, light is effectively infinite. It moves so fast, 300,000 kilometers per second, that it feels like a magical, instantaneous presence. Our ancestors, looking up at the stars, likely felt the same way. To them, the stars were just lights on a dome, distant but present, shining their light upon the earth without any sense of travel time. But the reality is more patient. The universe is more deliberate. To understand the light year, we must accept that every piece of light we see is a traveler that has survived a long, lonely journey. Even the light from the sun, which warms your skin on a summer afternoon, is a traveler. The Sun is 150 million kilometers away. That is a distance so large that the highway driving analogy breaks down. It would take you 150 years to drive there. You would be born, live your entire life, and pass away behind the wheel before you even made it halfway. And yet, for light, this journey takes only 8 minutes and 20 seconds. When you look at the Sun safely, through a filter or at sunset, you are not seeing it as it is now. You are seeing it as it was 8 minutes ago. If the Sun were to vanish this very instant, we would continue to feel its warmth and see its light for nearly 9 minutes, blissfully unaware of the change. We are always living in the recent past of the stars. This realization is our first step toward letting go of our human-scale perspective. We are moving from a world where everything is here and now to a universe where here is separated by vast thens. It is a shift from the concrete to the expansive. But do not let this make you feel small in a way that is cold or frightening. Instead, see it as a form of cosmic grace. The universe is so large that it allows us to see into the past simply by looking up. It provides us with a history book written in photons. As we prepare to leave the human scale behind and enter the first of our scale loops, take a moment to appreciate the sturdiness of your surroundings, your chair, the walls, the gentle rhythm of your breathing. These are your anchors. They are the zero on our cosmic ruler. From this safe, quiet vantage point, we are going to slowly extend that ruler, 1 light second, 1 light minute, and eventually 1 light year at a time. There is no rush to get there. The stars have been waiting for billions of years. They can wait a few more hours for us to arrive. For now, just hold on to the image of that single beam of light, leaving the Sun, traveling through the cold dark for 8 minutes, and finally reaching the Earth to illuminate a single leaf or a single window. It is a long way to go for such a small thing, but the universe is full of such journeys. With that in mind, let's move outward once more, to an even larger scale. We are leaving the comfort of the minutes and hours we know, and entering the realm where light begins its true marathon. To understand why we must abandon the kilometer and the mile, we have to look at the sheer inadequacy of our everyday numbers when applied to the celestial void. If we were to stay within our human scale perspective, the numbers would soon become so long that they would lose all meaning, becoming a mere blur of zeros that the mind instinctively ignores. This is why the light year exists, not just as a unit of measurement, but as a bridge for our imagination. Consider, for a moment, the distance across our own planet once more. If you were to take a standard ruler and try to measure the distance from New York to Tokyo, you could technically do it. The number would be in the millions of centimeters, perhaps, but it would be a number you could still write down on a piece of paper. But as soon as we point that ruler toward the sky, the scale shifts in a way that is almost humorous in its disproportion. Our world, with all its vast oceans and towering peaks, is effectively a grain of sand in a desert that has no end in sight. When we speak of human-scale perspective, we are also speaking of human-scale time. We measure our lives in decades. We measure our history in centuries. To us, 1,000 years is an unimaginably long time, 10 times the length of a long human life. It is the span of empires. Yet, in the context of the distances light must travel, 1,000 years is barely a heartbeat. To understand the light year, we have to marry these two concepts: the distance light covers and the time it takes to do it. It is a measurement that forces us to realize that looking out is the same as looking back. If you were to stand on a hill and look at a mountain range 50 kilometers away, you are seeing those mountains as they were a tiny fraction of a second ago. The delay is so small, roughly 0.00016 seconds, that your brain treats it as instantaneous. This is the comfort of the human scale. Everything we see is now, but as we move outward, this now begins to stretch and tear. By the time we reach the edge of our solar system, the now has become hours. By the time we reach the nearest stars, the now has become years. This is the human scale anchor slipping away, allowing us to drift into the deep drift phase of cosmic understanding. Imagine you are standing in a perfectly dark, quiet room. In the center of the room is a single candle. The light from that candle reaches the walls almost immediately. Now, imagine that room expanding. The walls move back miles, hundreds of miles, millions of miles. The candle remains in the center, a tiny, flickering point of light. If you are standing at the far wall, you have to wait. You have to wait for those tiny particles of light to cross the dark. This wait is the essence of the light year. It is the patience of the universe. In our daily lives, we are used to things being fast or slow. A car is fast compared to a walker. A plane is fast compared to a car. But light is the ultimate speed. It is the speed limit of reality. Nothing can go faster. And yet, even at this ultimate, impossible speed, the universe is so vast that light appears to crawl. To a photon, the trip from one side of a galaxy to another is a marathon that lasts longer than the entire history of the human species. When we use the term light year, we are acknowledging this paradox, that the fastest thing we know is still far too slow to make the universe feel small. Scientists understand this scale because they have to. Without the light year, the maps of the stars would be cluttered with numbers so vast they would be impossible to use in calculations. Imagine trying to describe the distance to a galaxy in inches. The number would have more digits than there are stars in the sky. The light year is our way of simplifying the infinite. It is a human-scale word applied to a non-human reality. It is a way for a creature that lives for 80 years to talk about a universe that has existed for 13 billion. As we settle deeper into this exploration, let the familiar world fade. The roads, the clocks, the schedules of tomorrow, they all belong to the scale of meters and minutes. Here, in the quiet expanse of the script, we are moving into the scale of the light year. This is a place where a short distance is trillions of kilometers. A place where recently means a few centuries ago. It is a safe place to be, because in this vastness, the small pressures of our lives find their proper perspective. They are not erased, but they are framed by a silence that has lasted for eons. Think of the light year as a long, steady breath. It is the distance light travels while the Earth makes one full trip around the Sunday. While you experienced 4 seasons, while you celebrated a birthday, while the trees grew and the snow fell, a beam of light was moving through the void, never stopping, never slowing, covering 9.5 trillion kilometers. It did this while you slept, while you worked, and while you dreamed. Every year of your life, light has added another light year of distance to its journey. This is the perspective we will carry with us as we move into our first scale loops. We will start with the small delays, the seconds and minutes, and gradually build our way up to the years, the centuries, and the millennia. We are not just traveling through space, we are traveling through time. And we are doing it together, safely anchored by the sound of this narrative. There is no need to hurry. The distance is already there, waiting for us to acknowledge it. The human-scale perspective is our starting point, our home base. It is the familiar that we will return to at the very end. But for now, we are going to let the anchor lift. We are going to let the shore of the familiar world recede until it is just a tiny, pale blue dot in the rearview mirror of our imagination. We are moving into the realm of the light year, where the distance truly begins to blow our human minds, not with noise or chaos, but with a quiet, breathtaking vastness. And for now, that uncertainty of how we fit into such a large map is simply part of the picture. It doesn't need to be resolved tonight. We are simply moving outward, step by step, light second by light second, into the beautiful dark ocean of the cosmos. Now, let's slowly expand outward. One level beyond what we just explored lies the speed of light itself. To grasp the distance of a light year, we must first become intimately acquainted with the traveler that defines it. Scientists understand a light year by observing the fastest thing in the universe. Light travels at about 300,000 kilometers every single second. This is a speed that defies our biological wiring. In the time it takes you to blink a mere fraction of a second, a beam of light has already circled the Earth 7.5 times. It is a speed that seems instantaneous to our human senses, yet in the grand architecture of the cosmos, it is the fundamental yardstick by which all things are measured. When you flip a switch in your home, the room is filled with light immediately. There is no perceived delay between the movement of your hand and the illumination of the walls. For all intents and purposes in our daily lives, light is omnipresent. But as we step away from our atmosphere and into the vacuum, we realize that light is not a state of being. It is a physical entity moving through space. It has a beginning, a middle, and an end to its journey. It is a constant, unwavering pulse that dictates the very rhythm of reality. To visualize this speed, imagine you are standing at the start of a long, straight track that stretches into the horizon. If you were to fire a laser beam down that track, by the time you could even begin to process the flash of the light, that beam would be thousands of kilometers away. If we compare this to our human-scale anchor, the disparity is almost humorous. A commercial jet travels at about 900 kilometers per hour. A beam of light travels at over 1 billion kilometers per hour. If you were to race the two, the jet would appear to be standing perfectly still, frozen in time, while the light vanished into the distance. What makes this strange is not just the speed, but the fact that this is the absolute limit. Astronomers didn't expect to find a universe with a hard speed cap, but nature has provided one. No matter how much energy you use, no matter how powerful your engine, you can never overtake a beam of light. It is the gold standard of the universe. And yet, even at this impossible velocity, the universe is so vast that light often appears to crawl. This is the central paradox of cosmology. The fastest thing we know is still far too slow to make the universe feel small. Imagine a single photon, a tiny packet of energy, leaving the surface of a star. It has no mass, no weight, and it experiences no time. From the photon's perspective, its journey from the center of the galaxy to your eye is instantaneous. But for us, standing on this small blue planet, we must wait. We must wait for years, centuries, or even millennia for that photon to complete its trek across the void. This waiting is what defines our perspective. It is why we cannot talk about distance in space without also talking about time. A light year is the marriage of the two, the distance covered in the time it takes the Earth to orbit the Sun once. As you listen to these words, think about the light in the room again. It feels now, but it is actually a few nanoseconds old. When you look at the person sitting across from you, you are seeing them as they were a billionth of a second ago. On Earth, this doesn't matter, but as we move outward, the lag becomes meaningful. If you were to stand on the moon and shine a laser back at Earth, it would take 1.3 seconds to arrive. If you were having a conversation with someone on the moon, there would be a gentle, rhythmic pause between every sentence, a 1.3-second gap that you could never bridge. And for now, that uncertainty is simply part of the picture. We can understand the math of the black hole, and we can calculate the distance of the light years, but the feeling of the scale is something that requires a different kind of attention. It requires the kind of attention you are giving it now, a soft, drifting curiosity that doesn't need to find a final answer. We are simply moving outward, step by step, from the familiar toward the infinite. Imagine the space between our galaxy and Andromeda. It is called the intergalactic medium. To our eyes, it looks like a perfect, empty blackness. But it is filled with a very thin soup of ionized gas, a scattering of atoms that are so far apart they rarely ever touch. This is the full silence of the void. It is a place where there is no sound, no wind, and no warmth. It is the ultimate buffer, a 2.5 million light year cushion that ensures the peace of the local group. As you settle deeper into your pillows, let the human scale fade away. You are no longer measuring the room or the time. You are beginning to measure your breath against the rotation of the stars. You are moving from the world of the grape and the salt into the world of the void and the halo. You are becoming part of the distance. The Andromeda galaxy is currently 15 quintillion miles away. It is a number that has no meaning in our daily lives. But the light is here, the gravity is here, the connection is here. We are tied to that distant island by the same fundamental laws that keep your heart beating and the earth spinning. We are part of the same story. With that in mind, let's move outward once more, to an even larger scale. We are leaving the anchors of the human perspective behind. We are letting go of the need for comparisons. We are moving toward the light-year bridge, where time and space become one and the same. The air in the room is still. The weight of your body is supported. The universe is vast, and you are a conscious part of it. You are the guest of honor at a cosmic viewing that has been 2.5 million years in the making. There is no rush to understand it all tonight. The stars will still be there tomorrow, and the galaxy will still be there in 1 billion years. For now, simply drift. Move from the small to the large. Move from the solid to the light. Move from the known to the magnificent unknown. Now, let's slowly expand outward. One level beyond what we just explored lies the concept of the light year. To understand Andromeda, we must understand that we are not looking at it as it is, but as it was. Scientists understand Andromeda by observing the light that has traveled across the void. Light is the fastest thing in the universe. moving at 186,000 miles every single second. In the time it takes you to blink, light has circled the Earth 7 times. What we know so far suggests that Andromeda is 2.5 million light-years away. This means the photons hitting your eyes tonight began their journey before humans even existed as a species. You are looking at an ancient ghost of a galaxy. But even with everything we've learned, there are still things we don't fully understand. We measure these distances with standard candles, stars that pulse with a predictable rhythm, but space itself is not a static stage. It stretches, it curves, and for now, that uncertainty is simply part of the picture. It doesn't need to be resolved tonight. With that in mind, let's move outward once more to an even larger scale. To bridge the gap between our comfortable, human-sized world and the silent majesty of Andromeda, we must rely on the fastest traveler in the cosmos, light. We have established that the distance is vast, but to truly feel the depth of the light-year bridge, we must consider what it means for a beam of light to spend 2.5 million years in transit. Light is the heartbeat of astronomy. It is the only messenger we have, a tireless courier that crosses the frozen desert of the void to bring us news of distant suns. In our daily lives, we treat light as instantaneous. When you flip a switch in your hallway, the darkness is replaced by a glow so quickly that your brain cannot register a delay. On the scale of your house, light is a ghost that occupies all space at once. But as we step out onto the porch and look up, we must realize that light has a speed limit. It is a frantic, blistering speed, 300,000 kilometers every single second. But against the backdrop of the great galaxy in Andromeda, even light begins to look like a slow-moving crawler. Imagine a single photon, a tiny packet of energy, leaving a blue giant star in the outer spiral arm of Andromeda. When that photon began its journey, the Earth was a very different place. There were no satellites orbiting the planet, no cities glowing in the night, no highways cutting through the forests. Our ancestors were walking across the plains of Africa, perhaps looking up at the same patch of sky, unaware that the very light we see tonight was already midway through its journey. This photon has spent every hour of every day for 2 million years traveling through a vacuum so perfect it would make a laboratory on Earth look crowded. It has seen nothing. It has hit nothing. It has simply moved forward, a silent arrow in the dark. Scientists understand this distance by using the concept of a light year, not a measure of time, but a measure of length. 1 light year is approximately 6 trillion miles. It is a number so large that if you tried to write it out in miles, the zeros would stretch across the page and lose their meaning. Andromeda is 2.5 million of these units away. If you were to build a bridge of paper, where each sheet represented the distance from the Earth to the Sun, you would need a stack of paper reaching into the clouds just to represent a single light year. To reach Andromeda, your stack would leave the atmosphere, pass the moon, and head out into the deep solar system. This is the bridge we are crossing tonight. It is a bridge made of time as much as space. When we look at Andromeda, we are looking at a living museum. We are seeing the galaxy as it existed during the Pliocene epoch. If a catastrophic event were to happen in Andromeda tonight, if 1,000 stars were to go supernova at once, we would not know. Our children would not know. Our great-great-grandchildren would not know. The news of that event is currently traveling toward us at the speed of light, but it is still millions of light years away. It is a letter in the mail that will not arrive for another 25,000 centuries. There is a quiet comfort in this delay. It means the universe is protected from its own volatility by the sheer magnitude of the light-year bridge. The explosions, the collisions, the births and deaths of stars, all of these events are softened by the distance. By the time the light reaches our eyes, the violence has passed. What we see is a calm, steady glow, a peaceful testament to a history that has already been written. The light year is the universe's way of ensuring that the present moment is a local experience, while the past is a communal treasure shared across the void. As you listen, imagine the space between the stars. It is not an empty blackness, but a sea of these traveling photons, all heading in different directions, carrying the stories of 1 trillion different suns. Andromeda is sending us 1 trillion stories every second. Some of that light is blocked by the dust clouds in our own Milky Way. Some of it is absorbed by the atmosphere of the Earth, but a tiny fraction of it, a few ancient photons, finds its way into your pupils. That light has completed its 5 million year journey just for you. It has crossed the bridge, survived the void, and finally come to rest. But even with everything we've learned about the speed of light and the distances of the stars, there are still things we don't fully understand. We speak of the constant speed of light, yet we know that space itself is expanding. While the light from Andromeda is trying to cross the bridge itself is subtly changing. In the case of Andromeda, gravity is winning the tug of war, pulling the galaxy toward us, shortening the bridge by a tiny fraction every day. In other parts of the universe, the bridge is stretching, growing longer than light can ever hope to cross. And for now, that uncertainty is simply part of the picture. We do not need to calculate the expansion of the universe to feel the weight of the years. We only need to recognize that we are part of a grand, slow-moving architecture. The light-year bridge is a structure of thought that allows us to step away from the minutes and hours of our day and enter into the deep time of the cosmos. As we move across this bridge, the details of our own world begin to blur. The houses, the streets, the familiar trees, they all recede into the distance. We are moving outward, beyond the orbit of the moon, beyond the golden warmth of the sun, and out into the indigo silence of the interstellar medium. We are following the path of the light, moving in reverse, back toward the source of the glow. On this scale, time is no longer a sequence of events, but a physical dimension. To look far is to look back. To understand size is to understand duration. The Andromeda galaxy is not just a place in the sky. It is a moment in the history of the universe that is still reaching out to us. It is a slow, steady pulse, a lighthouse on the edge of the local group, reminding us that the dark is not empty, and the distance is not a barrier, but a connection. With that in mind, let's move outward once more, to an even larger scale. One level beyond the individual beam of light lies the collective structure that holds those beams together. One level beyond the bridge lies the destination itself, the vast, rotating disk of the galaxy, where 1 trillion suns live out their lives in a slow, gravitational dance. We are leaving the narrow path of the light year and entering the wide, shimmering plains of the Andromeda disk. Here, the scale shifts again. We no longer count in single beams of light, but in the collective weight of stars. We are moving from the messenger to the message. As you drift deeper into this calm, imagine the light-year bridge as a long, quiet hallway. You are walking down this hallway, and at the end, a door is slowly opening. Through that door is the glow of 1,000,000,000,000 suns, a spiral of light that fills the horizon. You are safe. You are a passenger on a journey that has been unfolding since long before you were born and will continue long after. There is no hurry to reach the end. The bridge is long and the walk is quiet. The rhythm of the light year is the rhythm of your own breath, slow, steady, and inevitable. With every breath, you move another 1,000 miles along the bridge. With every exhale, you let go of another year. 2.5 million light years sounds like a burden, but it is actually a release. It is a distance so great that nothing you do today can possibly disturb it. It is a peace that cannot be broken. Scientists continue to measure the bridge, refining their numbers, checking their standard candles, and peering deeper into the dark. They want to know the exact length of the span. But for us, tonight, the exact number is less important than the feeling of the crossing. We are moving from the world of things we can touch to the world of things we can only imagine. And as we cross the midpoint of the bridge, we leave the influence of the Milky Way behind. We are now in the true void, the intergalactic space where there are no stars, no planets, and no heat. It is just us and the light and the distant, growing shape of Andromeda. It is a place of absolute stillness. In this stillness, the mind begins to settle. The light-year bridge has done its work. It has carried us far enough away from our lives that we can see them as part of a much larger tapestry. We are no longer individuals in a room. We are part of the light's journey. We are a brief, conscious moment in a 2.5 million year old story. And for now, that uncertainty is simply part of the picture. It doesn't need to be resolved tonight. With that in mind, let's move outward once more to an even larger scale. We are approaching the edge of the galaxy itself. We are moving from the bridge to the city of stars. To cross the distance between our familiar solar system and the great galaxy in Andromeda, we must construct a bridge made of light. A light year is not a measure of time, though it sounds like one. It is a measure of distance, the vast, staggering length that a photon travels in a single vacuum-sealed year. It is roughly 6 trillion miles. But numbers of this magnitude act like a sedative on the human mind. They are too large to feel, so we must find a way to walk across this bridge in our imagination, one step at a time. Imagine a single beam of light leaving the surface of a star in the Andromeda galaxy. This photon is our messenger. When it began its journey, the world you are currently resting upon was a very different place. 2.5 million years ago, the Earth was in the midst of the Pliocene epoch. The continents were roughly where they are now, but the life walking upon them would be unrecognizable to you. Early hominids were just beginning to navigate the savannas of Africa using basic stone tools, unaware that a beam of light was beginning a journey that would eventually end in the eye of a human being lying in a bed millions of years in the future. This bridge is remarkably empty. For most of its 2.5 million year trek, our photon has encountered absolutely nothing. It has passed through a void so profound that the densest parts of it contain fewer atoms than the best vacuum chambers ever built by human engineers.